All right, let's talk about something fascinating. We're going to follow a scent trail, a really surprising one. It connects a sense we barely think about to one of the most feared diseases of the brain.
I mean, think about it. Could a simple smell test really be an early warning for something as complex as Alzheimer's? It sounds almost too simple, right? Alzheimer's is this huge challenge, it affects so many people, and catching it early is, well, it's everything. So what if the key has been literally right under our noses this whole time? Let's get into it.
Believe it or not, this whole story kicks off back in 2013 with a jar of peanut butter. I know, it sounds weird, but researchers at the University of Florida did this really simple test. They had patients close their eyes, plug one nostril, and then they'd bring a ruler and some peanut butter closer and closer until the person could smell it. Then they'd switch nostrils and do the exact same thing. And the results they got were super specific.
So get this. For patients who likely had Alzheimer's, their left nostril was way worse at picking up the scent. The left one, specifically. And that's not just some random detail. Our sense of smell is what we call ipsilateral. The left nostril reports to the left side of the brain. And where does Alzheimer's often start its destructive path? Yep, the left side of the brain. So this was a huge, tantalizing clue.
Okay, but here's the thing about science, right? One study is never the final word. A year later, another team tried to do the exact same peanut butter test, and they couldn't get the same results, and that's totally normal. That's how science works. It just meant the peanut butter test itself wasn't the magic bullet, but it had lit a fire. It pointed everyone in a really promising direction.
So the scientific community picked up that scent trail and started digging for some more solid evidence.
And wow, did they find it. A huge study out of the University of Chicago, following almost 3,000 people, dropped this bombshell. Older folks who had a hard time identifying common smells were more than twice as likely to develop dementia in the next 5 years. And notice the key word there, identifying. This was a step beyond just detecting a smell, like with the peanut butter. This was about knowing what you were smelling.
They use these things called sniff and sticks. They kind of look like pens, but they're filled with these really specific scents. Peppermint, fish, orange, rose, and leather. Pretty common smells, right? But here's the kicker. If someone couldn't get at least 4 out of those 5 right, they were flagged as high risk. All of a sudden, this link between smell and brain health wasn't just a quirky idea anymore. It was getting serious. All right, so to really zero in on this, scientists started looking at a specific group of people, those with a gene variant called APOE4. Now, this gene is a major risk factor for Alzheimer's. About a quarter of us carry it, and it shows up in something like 40% of people with the disease. So the big question was, okay, if we look at just these high-risk folks, is the smell connection even more obvious? And yep, a huge study tracked these gene carriers for years and found this incredible step-by-step pattern. First, starting around age 65, their ability to just detect an odor started to go. Then, maybe a decade later, their ability to identify what that smell was, that's when it really took a nosedive. And here's the most important part. This was all happening before the classic memory problem showed up. The loss of smell wasn't just another symptom. It looked like a warning shot, a prequel to the disease itself.
So okay, the link is definitely there. It's strong, but just because two things happen together doesn't mean one causes the other, right? The why was still a huge mystery. What was physically going on inside the brain that was causing this?
Well, the most obvious suspect was this little structure called the olfactory bulb. You can think of it as the brain's post office for smell. It's the first place all the scent information from your nose goes. The logic seems simple. If the sense of smell is failing, this post office must be shutting down, right? It must be shrinking or getting damaged. So they brought in the heavy machinery, MRI scans, to take a look.
But the results were not what anyone expected. It was a total curveball. In people with early mild Alzheimer's, the very people who were already losing their sense of smell, the olfactory bulb was fine. It was basically the same size as in healthy people. It only started to shrink way later in the disease. This just didn't make sense. So now we have a real puzzle on our hands. If the main smell center isn't damaged, what on earth is causing the problem? It felt like the trail had gone completely cold. How could you lose your sense of smell if the part of your brain responsible for it was still intact?
And just when it seemed like a dead end, a breakthrough. A team of German researchers found the answer, and it was wild. It turns out the brain wasn't just being attacked by a disease, it was actually attacking itself.
So here's the big reveal. The problem wasn't the post office, the olfactory bulb, it was the roads leading to and from it. The connections, these long nerve fibers called axons, were being severed.
The components were fine, but the wiring was being ripped out. And get this, the ones doing the ripping were the brain's own immune cells. Let me introduce you to the microglia. These are the brain's dedicated security guards and cleanup crew. Their job is to patrol around, get rid of debris, and fight off invaders. They're the good guys. But in the very early stages of Alzheimer's, something goes terribly wrong, and these protectors, well, they turn into villains.
So here's what the researchers figured out. For some reason, way before the brain cells themselves start to die, the connecting wires, the axons, start putting out these weird little flags on their surface. It's basically an "eat me" signal. The microglia, our security guards, see these flags and think, oh, that's trash, and they do their job. They destroy it. So the brain cell itself is still alive, but its phone line to the rest of the brain has been cut. And for reasons we're still figuring out, this seems to happen first and worst in the pathways for our sense of smell.
This is so much more than just solving a cool brain mystery. Understanding this process completely changes the game for how we might be able to spot and maybe even one day fight this disease.
I mean, let's be real. Diagnosing Alzheimer's early right now is hard. And we all know that getting that early diagnosis is everything. It's the only time treatments really have a chance to work. But the tools we have, things like PET scans and spinal taps, they're invasive, they cost a fortune, and most people just can't get access to them.
Now, just imagine the future this research points to. Instead of a $5,000 scan you have to go to a hospital for, what about a simple smell test that shows up in your mailbox? Something cheap, something you can do at home, something that could screen millions of people and flag those who are at the highest risk years before they even notice a problem. That's not just diagnosis, that's getting out ahead of the disease.
And as Dr. Pinto, who led that big Chicago study, said, the point isn't even to have a perfect, 100% accurate test right away. The goal is to have a simple way to mark someone for closer attention. It's about building an early warning system so we can get the right people into clinical trials for new drugs and give treatments the absolute best shot at making a difference.
So it all comes full circle, doesn't it? From a weird test with a jar of peanut butter all the way down to the brain's own immune cells making a tragic mistake. This whole journey was about scientists noticing a clue that was literally hiding in plain sight. And it really makes you wonder, right? What other simple signs, what other secrets about our brain's health are we overlooking every single day?